In these notes, we're going to be solving log equations. In order to do this, we need to use our properties of logs. So if you don't remember your log properties, you may want to go back and look at your notes on properties of logs. So that would be condensing and expanding logs. For number 1, I'm going to combine my two logs on the left using the product property, which tells me I can combine these into a single log because they're the same base, where I multiply the arguments. So x times 5 or 5x. Once I have them combined into a single log, I can then rewrite this log as an exponential equation. So I'm going to rewrite this. Remember that if there is no base given, it's automatically a base 10. And then we write to the power of 1 equals, our argument becomes our solution, 5x. So right now we have 10 to the power of 1, which is 10, is equal to 5x. And then we simply solve for x. Divide both sides by 5. We get that x equals 2. For number 2, we're going to combine these two logs using the quotient property. So if I'm subtracting logs, I would divide. Now notice we have this 3 coefficient. So before I can combine these, I'm actually going to need to move that as an exponent using the power property. So we have log base 5 of x cubed minus log base 5 of x is equal to 2. Then I combine these with the quotient property. We get log base 5 of x cubed divided by x equals 2. All right, now at this point I could go ahead and rewrite it as an exponential equation, or you may notice that I can simplify this argument. So that's what we're going to do. We're going to simplify that. So this becomes log base 5, x cubed divided by x is just x squared. This whole thing is equal to 2. I'm going to move this over here so we can solve it. We have log base 5 of x squared is equal to 2. Now we need to rewrite this. So our base is 5 raised to the exponent of 2 is equal to x squared. So if 5 squared is equal to x squared, then our x equals 5. Okay, for number 3, we're going to combine these using the quotient property. Since they're both base 3, I can rewrite this as a single log, base 3, of x divided by 4, and this is equal to 2. Now that I've condensed it to a single log, I can rewrite it as an exponential equation. My base is 3 raised to the power of 2 equals x over 4. Now we can solve 3 squared is 9 is equal to x divided by 4. Sorry, that's a 5. X divided by 4. And then we're going to multiply by 4 on both sides. And we get 36 is equal to x. And number 4, and notice these are both log base 7, so I can combine them into a single log. Since they're being added, I'm going to use the product property, which tells me that I can multiply my arguments. So we'll multiply x plus 1 times x minus 5 and set the whole thing equal to 1. Now that I've condense this into a single log, I can rewrite it as an exponential function. So our base is 7 raised to the power of 1 is equal to, and this entire multiplication is our argument. So our solution is then x plus 1 times x minus 5. Okay, now we need to solve for x. So we have 7 to the power of 1 is 7 is equal to x squared minus 4x minus 5. Since you have a quadratic, remember the only way to solve a quadratic is by setting it equal to 0. Once you have it set equal to 0, the quickest way to solve would be factoring. And since two numbers multiplied by each other to get to 0, one of them has to be 0, so we can actually set both of them equal to 0. We get 6, and we get a negative 2.